Hello everyone and welcome back to Theory 4. This is video 8, our last 20th century techniques video. In this video you will learn about asymmetrical meter, mixed meter, polyrhythm, polymeter, metric modulation, ametrical music, and additive rhythm. An asymmetrical meter is any time signature that does not yield a constant grouping of durations. This could be something like 5/8, 7/4, or 11/8, or anything like that. What usually ends up happening is that you have mixed groups of 2 and 3 pulses. Here's an example by Bartók in 7/8, grouped as 4 plus 3. And we can count this as 2 plus 2 plus 3. So 1, 2, 1, 2, 1, 2, 3, 1, 2, 1, 2, 1, 2, 3, 1, 2, 1, 2, 1, 2, 3, etc. And here's what that sounds like. In this example, Bartók writes the groupings right into the time signature. So here we have 8 eighth notes in a measure, but he doesn't want us to count it like 4/4 or even 8/8. Instead, the groupings are 3 plus 3 plus 2, and we count it 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2. Now I'm going to play this slowly so that you can hear these groupings, and then I'll play the recording that goes much, much faster. So the groupings go like this. Etc. And now I'll play the recording where it's much, much faster. Next, I want to talk about 2 classic rock songs. I can't play them in this video because YouTube will pull it for copyright if I do. But what I can do is tell you how to count them. The first song is Living in the Past by Jethro Tull. It's in 5/4, but that 5/4 is divided as 3 plus 3 plus 2 plus 2. So 1 and 2 and 3 and 4, 5. 1 and 2 and 3 and 4, 5. 1 and 2 and 3 and 4, 5. And it does that all the way through the song. I'm putting the video for this right after this video in the playlist so you can hear it. Another one that I like a lot is Whipping Post by the Allman Brothers Band. Most of this song is in 12/8, but the introduction and all of the guitar interludes are in 11/8. And it's divided 3 plus 3 plus 3 plus 2. So it's like 12/8 with the last eighth note dropped. As you listen, you can count along 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. I'll put this one on the playlist after this video as well. When we talk about mixed meter, we simply mean frequently changing time signatures. This is yet another example from the Bartók Mikrokosmos, and you can see that the meter changes every measure, and that's all mixed meter is. Within that mixed meter, you can also see a couple measures of 5/8, which is an asymmetrical meter. In this case, it divides 3 plus 2, which you can most easily see in the last measure of the example. A polyrhythm is when 2 different complex rhythms occur at the same time. And a polyrhythm usually happens within a beat or measure, and it does not disrupt the overall time signature. In other words, beats and bar lines will tend to stay consistent. When I say complex rhythms, I mean that the rhythms don't agree with each other and they don't line up neatly. In this example, there are 3 polyrhythms. In the first measure, 3 against 4 on beat 1, and then 5 against 3 on beat 4. Then the entire second measure is a polyrhythm because we have 6 against 7. And here's what that sounds like. Polymeter happens when 2 different time signatures are going on at the same time. This is different from polyrhythm. Polymeter happens across measures, and it sounds like 2 or more different streams of time signatures. Visually, this can be done with misaligned bar lines. In other words, the bar lines won't line up vertically across the different parts. Or composers can simply use phrase markings and gestures to create the opposing meters. In the next two examples, we'll see one of each kind. The first is a duet in your Berkowitz sight singing book, page 328, duet number 137. You'll see that the time signatures are 3/4 in the bass part and 4/4 in the treble, and that the bar lines don't line up. After that, we'll revisit a piece that we looked at in video 2 on pentatonic scales. That's Les Ranettes, Empress of the Pagodas by Ravel. This one is written in 2/4 with regular bar lines, but the polymeter is created using slurs and gestures, and the left hand, at least in parts, sounds like it's in 3/4. Here's the Berkowitz example. Notice the two different time signatures and the misaligned bar lines. Now the treble part is in 4/4 and goes like this. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, and etc., like that. The left hand is in 3/4, and you can see this not only with the time signature, but the gestures, how the note C occurs on the downbeat in the first three measures, and the note D after that. The left hand goes like this. 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, etc. Now I'm slowly going to put these together. Etc. So you can kind of choose one of those and count along with it, whichever one you like. And here's the Ravel example. The written score has a constant time signature of 2/4, but Ravel creates a polymeter beginning in the middle of measure 5. He does this with a repeated upward gesture, which is actually an ostinato, that lasts for 3 beats. And what we see here is a layer of 2/4 in the melody and 3/4 in the accompaniment. This continues for a while, then you'll see it change back to 2/4 and then to 3/4 again. Here's what it sounds like. A metric modulation is actually a tempo change and not necessarily a meter change. The tempo change happens when the composer designates that a note value in the old tempo becomes equal to a note value in the new one. In this example, the first metric modulation happens at the 3rd bar, where the 8th note in 9/8 becomes equal to the 16th in 2/4. 2 bars later, the 8th of 2/4 becomes the dotted quarter in 12/8. The first modulation slows the tempo a bit, and then the second one speeds it way up. Here's what that sounds like. Ta 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 ta. If you need to go back and listen to that again, go ahead and maybe sing along with it to get the feeling of how those metric modulations work. Here's an example from real music. The composer Elliott Carter was known for very complex rhythms and for metric modulation in particular. This example is from a set of pieces that he wrote for timpani, and that's just for timpani alone. So notice the metric modulations just before measure 11, and then also from measure 17 to the end of the example. And here's what that sounds like. Ametrical music is simply music without a meter, which means no time signature and no regular pulse groupings. It is organized only with note durations and groupings at the local level. Often there are no bar lines, but if bar lines are present, they're only a convenience to the performers so they can stay together. Gregorian chant is an example of ametrical music. On the next page, we'll look at an ametrical work by Ruth Crawford Seeger, Piano Study in Mixed Accents. There is no time signature, there are no bar lines, and the piece is all 16th notes organized in groups of 3, 4, 5, and 6. Here is that example, and here are the groupings, and here's what it sounds like. Additive rhythm is a process where a composer creates new values by adding or subtracting values from some of the notes. So let's take a 5-beat measure that we would count like this. Ta 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 ta. Now let's mess with some of the notes. We could take the first pair of 8th notes and just insert a 16th note between them. And then on the quarter note, we're going to subtract a 16th note from that, so that leaves us a dotted 8th note. And then for the half note, let's tie a 16th note to it, and that will give us a duration of 9 16th notes. And finally, the second to last 8th, we'll subtract a 16th from that, leaving us with just a 16th and an 8th. And the result is that we have this sort of lopsided rhythm that goes against the traditional binary organization that we're used to hearing. We can't count this 1 and 2 and 3 and 4 and 5 and anymore. So it makes sense that when you have an additive rhythm that you will have ametrical music. Performers have to count something like this just using the smallest note value, which in this case is the 16th note. So our resulting rhythm, if these are the 16th notes, would sound like this. Ta, 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 ta. This excerpt is from a piece by Olivier Messiaen, the Quartet for the End of Time, and it's written for a rather unusual instrumentation. The quartet is violin, clarinet, cello, and piano. And the reason for that is that Messiaen wrote this piece while he was a prisoner of war in World War II. He played piano, and 3 of his fellow inmates played the other instruments. So in other words, he wrote for what he had. This is a really wonderful piece. It's one of my favorite pieces ever. If you don't know it, look it up and listen to it. If you do know it, go back and listen to it again. It incorporates religion and mysticism and math and bird songs and all kinds of wonderful things. So in this example, the movement is called Dance of Fury for the 7 trumpets, and there are no trumpets playing, but what you will hear is all 4 of the instruments playing together in unison or in octaves. So what we're looking at here is just the piano part. All the other instruments are doubling it. You'll see that it's mostly 8th notes, quarter notes, and some half notes, but occasionally, like in the first measure, he'll just stick a 16th note between 2 8th notes. And then he adds another 16th note in the middle of the second measure. And later on in the fourth measure, just before the half note, he'll tie on a 16th note to that 8th note. So there's the dotted 8th note C there that's worth 3 16th notes. And he does this again on the second to last note. Again, we'll have that kind of lopsided feeling, and the bar lines do not indicate any meter. This is an ametrical piece, but they tell the performers where to phrase. So you'll see a bar line after every note that's relatively longer than the other ones. Well, we made it to the end of the last one. Thank you for sticking with me. Up next, just some things that I think you'll enjoy listening to. Some selections from the Bartok Mikrokosmos, a lot of asymmetrical meter with groupings of twos and threes, really fun pieces. Also, a couple of those rock songs that I was talking about, the Allman Brothers Band and Jethro Tull, that have asymmetrical meters. I'm including a performance of Canaries. That's the timpani piece by Elliott Carter, and I really think you should see this thing performed. It's pretty amazing. And finally, when you're ready, quiz number 3 awaits you. After that, we can start talking about the comp project. I plan to really kick that into high gear next week. So be watching for that, and we're almost through this, guys. Take care, stay safe, and I miss you lots. Bye.